Hi, this is MD Shabana Sultana, working as Associate Professor in the Chaparral Engineering College, Chaparral. Today, I want to discuss about the chemistry of materials, in that nanomaterials. What is a nanomaterial? The materials like the metals, ceramic, polymeric materials, or composite materials with dimensions and tolerance in the range of 1 nanometer to 100 nanometers are called nanomaterials. A nanomaterial, in that a nanometer ion, 1 billionth, that is 1 billion means 10 power minus 9 of a meter is the unit of measurement. That means 1 meter is equal to 39 inches or 3 feet. 1 by 100 of the meter is called centimeter, and 1,000 of a meter is called millimeter, and 1 by 10 lakhs of a meter is called micron or micrometer, which is a scale of the most integrated circuits and micro electromechanical system. In the overall view, the nanomaterial is defined as the material is having at least one dimension in a nanometer range, that is 1 to 100 nanometer. Nanometer have a great significance scientifically because they are effective intermediate between the bulk material and atomic or molecular structure. And the size range is also in between the bulk material and atomic or molecular structure. And this nanometer is used to measure the objects which are very small in size. That is, for example, if the size of the hydrogen atom is 0.1 nanometer, water molecule is less than 1 nanometer. RBC count, that is a red blood corpuscles count, is 5,000 nanometer, and a human hair is 50,000 nanometer. The limit of human eye visibility is 10,000 nanometer. The diameter of the carbon nanotube is 1.3 nanometer. So it is used to measure the objects of a very, very, very small in size. Coming to the significance of the nanomaterial, the significance is due to its small size. They exhibit the unique property, that is, they are different from that of the observed in bulk material, like melting points, reactivity, etc. Reaction rate, electrical conductivity, color, transparency, etc. Nanomaterial may be biological, inorganic, or organic by their origin. A nanoparticle is defined as a small object that behaves as a whole unit in terms of its transport and properties, and exhibit a number of special properties related to the bulk material. And basically, there are two types of approaches are there for the preparation of nanomaterial. Basically, there are two types of approaches are there. For the preparation of the nanomaterial, they are top-down approach and bottom-up approach. Here it is a bottom-up approach is there. Likewise, top-down approach is also there. Top-down means from top to bottom. That means in this type, the bulk material are converted to powder and then to nanomaterial, that is a nanoparticle, by making the use of lithographic method. And this method is widely used in the microelectronic industry. Whereas this bottom approach processes very small particles like individual molecules or atoms are assembled to get the clusters, which in turn are aggregated to get nanoparticles. So this method is used to prepare the new class of nanomaterial. The best example for this is a fullerene, which I'll discuss later in the next lectures. Based on that type of approaches, the nanomaterial can be prepared by sol gel method. Sol gel. This sol gel method, it is an example of the bottom-up approach or bottom-up process for the synthesis of nanomaterial. And it is very well known since 1980s. The versatility of this technique has been rediscovered in the year 1970s when glasses are produced without high temperature melting process. The sol is a colloidal or molecular suspension of solid particles of ions in a solvent. A gel is a rigid mass that forms when the solvent from sol begins to evaporate and particles or ions are left behind, begins to join together in a continuous network. So this sol gel process is a wet chemical process. Is a wet chemical technique that uses a sol to produce an integrated network, that is gel. For example, we take the metal oxides or metal chlorides. It undergo hydrolysis and polycondensation reaction to form a colloid, which is a system composed of nanoparticles dispersed in a solvent. The solvent evolves towards the formation of an inorganic continuous network containing a liquid phase, that is a gel. Formation of metal oxide involves connecting the metal center with oxo, that is MOM linkage. This MOM linkage, or hydroxo, that is MOHM linkage. It forms a bridge generating the metal oxo and metal hydroxo polymer in a solution. After the drying process of the liquid, the liquid phase is removed from the gel and calcinated is performed in order to enhance the mechanical property. And alcohol is used as a solvent in this process. And a sol is a stable dispersion of colloidal particles or polymers in a solvent, whereas the sol particles may interact by the van der Waals forces or hydrogen bonds, and a gel consists of three-dimensional continuous network forms when the solvent from the sol begins to evaporate. So in a colloidal gel, a network is built by combination of the colloidal particles. That means a colloidal solution which on the process of hydrolysis and polycondensation reaction to form a colloid, which is a system composed of nanoparticles dispersed in a solvent. So this is about the solvent particle, sol gel method, in which the metal is extracted from the precursor of the metal oxides and metal chlorides. That's why this sol gel process is known as the wet chemical technique that uses either the chemical solution or colloidal particles to produce an integrated network, which is known as the gel. This MOR, NR, MOACN is a metal oxide and metal chlorides, which are commonly used as a starting material. And these are dispersed in a solvent known as alcohol to produce a colloidal solution. The colloidal solution undergo hydrolysis and polycondensation reaction to form inorganic continuous network-like structure. And the reaction involves the connecting the metal centers with MOM or hydroxy bridges, thereby generating the metal oxide and metal hydroxide polymer in a solution. After the drying process, the liquid phase is removed from the gel. Then, a thermal treatment known as the calcination process may be performed in order to favor further condensation and enhances mechanical property. Coming to the advantages of the sol gel method, it is able to get a uniform and a small size powder, and it can be carried out at the low temperature and get a new microstructure and composition which is having a low temperature. And it can produce the uniform multi-component system which is having a better control over the reaction. So this is about the sol gel method. Next one is a characterization of the nanoparticles. The characterization of the nanoparticle can be done by using three types of methods. They are the Beck method, SEM method, and CHEM method. Coming to the first one, that is a Beck method. Beck method means it is a Brunner-Emmett-Teller method. And this method is used to determine the specific surface area of the nanoparticle by absorption of an inert gas on the surface. Nanocrystalline particles are synthesized by the combustion reaction method in that the sample is first weighed and placed in the vacuum chamber. Why the sample you have to keep in the vacuum chamber means to remove the moisture and the adsorbed gases. After taking out the sample from the vacuum chamber, the sample, it is cleared or pure without having any moisture and the absorbed gases. Then it is cooled at a constant temperature by means of the liquid nitrogen. After that, the nitrogen gas is absorbed on the surface. Absorbed. That means absorbed means it is a surface phenomenon. So it gets absorbed only on the surface of the sample. From the amount of the gas absorbed at a given pressure, an absorption isotherm is derived. And this Beck method, it is used to determine the amount of the gas necessary to the monolayer capacity. From the monolayer capacity, the specific surface area can be calculated. Other than the nitrogen gas, Other gases such as argon or krypton can also be used as an adsorbed gas. And the Brunner, Emmett, and Teller, they gave the relation and the formula to calculate or to determine the specific surface area of the nanoparticle, that is 1 by V into P naught by P minus 1 is equal to 1 by VMC plus C minus 1 by VMC by P naught. Whereas P is known as the equilibrium pressure, P naught is known as the saturation pressure of the adsorbate at the temperature of adsorption. Whereas V, it is known as adsorbed gas quantity, whereas Vm is known as the monolayer adsorbed gas quantity. And C, it is a constant which is known as the bed constant. This bed method, one important point we have to note down is the dry samples is required to determine the surface area, specific surface area of the nanoparticle. Wet samples, it is of no use. And it is a fast and relatively cheaper method. Next, coming to the transmission electron microscopy. This method is used to determine the primary particle size, aggregate particle size, and agglomerate size of the nanoparticles. And this is a shape control method for the synthesis of colloidal platinum nanoparticles, which is potentially important in the field of catalysis. Catalytic reactivity depends on the size and shape of the particle. Coming to the working of the transmission electron microscopy. This transmission electron microscopy is a technique. Involves a beam of electron which is transmitted through the thin sample. That means, here it is a working. It is a beam of electron which is to be transmitted to the thin sample. From interaction of the electron transmitted through the sample, image is formed. It should be recorded. This image is magnified and focused onto imaging device for viewing a sample or for record of a sample. To record the sample and to read the sample, this image is magnified and focused on the imaging device. Areas of dense material, that is a solid nanoparticles, absorb the electrons and appears as a dark area on the viewing screen. The viewing screen is appearing as a dark area because the material is a very dense material. There is a very solid nanomaterial is there. That's why it absorbs the electrons and appears as a dark area. And less dense material, that means it is not having that much of solid as when compared to the former case, that is such as the coating around the nanoparticle. That means if the nanoparticle is being get coated, that coating material it considered as a less dense material. It allows the electron to pass through and appears as a lighter area. Finally, the image will be in this method, that is a TEM method. Final image will be 200,000 times than the normal magnification. So this STEM method, it is capable of achieving a magnification as high as 1 million, but the quality of the image decreases as the magnification increases. That's why I told you that this is a shape controlled method for the synthesis of colloidal nanoparticles. So this is about the TEM method. In the next lecture, I'm going to tell about the SEM method as well as the graphenes. Thank you.